Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. So before us is a typical examination question on mass, moles, and volumes. We'll talk about the stoichiometry. We're just trying to give the relationship between mass, moles, and volume. So this is a typical examination question, A-level question. It's a very simple question, but somehow technical because it's an A-level question. So please, we need to look at it critically, read the question very, very well, and understand every concept that has to do with the question. Now, a student reacts 4 mole of ammonia with oxygen to produce an oxide of nitrogen and water only. Each nitrogen atom increases its oxidation state by 5 in the reaction. How many moles of oxygen gas react with 4 mole of ammonia in this reaction? Now, the first thing to do, just as I say, is to understand the question very, very well. So it's student react 4 moles of ammonia. So we're going to write the equation for the reaction. 4 moles of ammonia with oxygen to produce an oxide of nitrogen. We don't know the oxide plus water. Now, according to the question, each nitrogen atom increases its oxidation state by 5 in the reaction. So there's an increase in the oxidation state of nitrogen by 5 in the reaction. So what we'll have to do is to calculate the oxidation number of nitrogen in ammonia. So let's calculate the oxidation number of nitrogen in ammonia. So nitrogen is N plus 3 bracket. Oxidation state of hydrogen is plus 1. Plus 1 will be equal to 0. So nitrogen 3 times 1 will be 3 plus 3 is equal to 0. So the oxidation state of nitrogen will be equal to if plus 3 crosses over, we'll have 0 minus 3. So nitrogen will be equal to minus 3. Now the oxidation state of nitrogen in ammonia is minus 3. And according to the equation, the nitrogen atom increases its oxidation state by 5. So it will now be minus 3 plus 5, which will now be equal to plus 2. That means the oxide of nitrogen, we have an oxidation state of plus 2. That oxide of nitrogen that is formed, the oxidation state of nitrogen in that oxide will be plus 2. So that means the oxide is NO, which is nitrogen oxide, which is nitrogen 2 oxide, an oxide of nitrogen. So it will be NO. So the next thing to do is to balance the equation for the reaction. We have to balance the equation. Nitrogen is 4 here, nitrogen, so we put 4 here to balance nitrogen. Hydrogen is 12 here, so we'll put 6 here. Hydrogen will be balanced on both sides. 6 times 2, 12, 4 times 3, 12. So what is left is oxygen. On the product, oxygen is 4 plus 6, oxygen is 10. So on the reactant, oxygen is 2, so we'll add 5 here. So oxygen is now balanced. Oxygen is 10 on the reactant, and oxygen is also 10 on the product. So the equation is balanced. Yana asks how many moles of oxygen gas react with 4 mole of ammonia in this reaction. So if we look at the stoichiometry of the reactant, that means 4 moles of ammonia gas react with 5 moles of oxygen. So the answer to this question is 5 mole of oxygen. It is 5 mole of oxygen that reacts with 4 mole of ammonia. So the answer to this question is B. So it's as simple as A, B, C. All you need to do is to read the question very, very well and understand the question before attempting the question. Please solve as many questions as possible and reach out to me if you encounter any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you for listening. I'm always there for you. Reach out to me. Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. So before us is a typical A-level questions, exam style questions. It's very simple and straightforward, but a little bit tricky. So you have to read the question properly and understand the question before attempting it. It's on mass, moles, and volumes. Sodium peroxide, Na2O2, is used to absorb carbon dioxide from the atmosphere and release oxygen in closed environments, such as space capsules and submarines. 2 moles of sodium peroxide react with 2 moles of carbon dioxide to give you 2 moles of sodium carbonate and 1 mole of oxygen. Which mass of sodium peroxide will be required to remove 2.4 dN³ of carbon dioxide gas from the atmosphere at room temperature and pressure? So it's as simple as ABC. The first thing you have to do, you have to focus on the reactant the reactant or the product that is demanded. So we have to do it has to do with what mass of sodium peroxide that will be required to remove 2.4 dn cube of carbon dioxide. So we are dealing with what sodium peroxide. We are dealing with sodium peroxide. So we are dealing with sodium peroxide and what carbon dioxide. So it's very, very simple. So from the equation, if you look at the equation that is given to us here, that means 2 moles of sodium peroxide react with what? 2 moles of carbon dioxide gas. And remember, 1 mole of any gas occupies a volume of what? 24 dn cube. And carbon dioxide is a gas. So 1 mole of carbon dioxide gas at room temperature and pressure occupy a volume of 24 dn cube. So 2 moles of carbon dioxide will occupy a volume of what? 2 times 24 dm cube, which is equal to what? 48 dm cube. That means from the equation, 2 moles of sodium peroxide, moles of what? Sodium peroxide require what? Would be required 48 dm cube of what? Carbon dioxide, with 8 dn cube of carbon dioxide gas. So 2 moles of sodium peroxide will react with what? 48 dm cube of carbon dioxide gas. So that means 2.4 dm cube of carbon dioxide gas will require what moles of sodium peroxide? What moles of sodium peroxide? So that is it. So which mass of sodium peroxide will be required to remove 2.4 dn cube of carbon dioxide from the atmosphere? So if 2 moles of sodium peroxide would react with what? 48 dn cube of carbon dioxide gas. So that means 48 dn cube of carbon dioxide gas will react with 2 moles of sodium peroxide. So 2.4 dn cube of carbon dioxide gas will require what? What moles of what? Sodium peroxide. So we'll have to cross multiply. So X now will be equal to what? 2 times what? 2.4 divided by what? 48. So if I'm to use my calculator, 2 times 2.4, 2 times 2.4 is equal to, divided by 48, divided by 48, which will now be equal to 0.1 moles. So it requires 0.1 moles of what? Moles of sodium peroxide. Na2O2. So it requires 0.1 mole of sodium peroxide. So we have to calculate the mass of sodium peroxide that will be required to remove 2.4 dn of carbon dioxide gas. So we've calculated the number of moles of what? The number of moles of sodium peroxide that will be required to remove 2.4 dm cube. So we have to calculate the mass. So let's calculate the mass. So I have to erase this. So to calculate the mass, remember we use our formula. Number of moles is equal to what? Mass over what? Molar mass. So the mass now will be equal to what? The number of moles times what? Molar mass. So the number of mass now will be equal to, what is the number of mole of what? The number of mole of sodium peroxide is what? 0.1 times the molar mass of what? Sodium peroxide. So I have to calculate the molar mass, which is 2 bracket what? 23, which is the relative atomic mass of sodium, plus 2 bracket 16, which is the relative atomic mass of oxygen. So it will now be equal to 46 plus what? 32, which is equal to 46 plus 32 is 78. So the mass now will be equal to 0.1 times what? 78. 0.1 times 78, which will be equal to what? 7.8 gram. So the mass of sodium peroxide that will be required to remove 2.4 dn cube of carbon dioxide is 7.8 gram. So the answer to this question is what? C, which is 7.8 grams. So it's as simple as what? A, B, C. So attempt as many questions as possible and feel free to reach out to me if you encounter any difficulty. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. So please reach out to me for any challenge or any difficulty. I'm always there for you. Thank you very much. Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. So before us is a typical examination questions on A-level, exam style question on mass, moles, and volumes. So it's a very simple and straightforward question. Please, I want us to listen attentively, read the question thoroughly, understand the question before attempting it, because it's a little bit tricky, but it's simple and straightforward. Sodium peroxide, Na2O2, is used to absorb carbon dioxide from the atmosphere. and release oxygen in closed environments, such as space capsules and submarines. So from the equation, if I look at it, you can look at the stoichiometry of the equation: 2 moles of sodium peroxide react to 2 moles of carbon dioxide to give you 2 moles of sodium carbonate and 1 mole of oxygen. You are now asked which mass of sodium peroxide will be required to remove 2.4 dn³ of carbon dioxide from the atmosphere at room temperature and pressure. It's as simple as ABC. Remember, 1 mole of any gas occupies a volume of what? 24 dn³ at RTP, which we call molar volume of gases. 1 mole of any gas, 1 mole of any gas occupies a volume of what? 24 dn³ at RTP. So you're now asked to calculate the mass of sodium peroxide that will be required to remove 2.4 dn³ of carbon dioxide. So you look at the stoichiometry of the equation, you concentrate on the what? On the reactant, that is demanded from the question. And the reactant is sodium peroxide, and what? Carbon dioxide. So 2 moles of sodium peroxide react with 2 moles of carbon dioxide. So the first thing to do is to calculate what? The mass of 2 moles of sodium peroxide. So which will now be 2 bracket what? 2 times the relative atomic mass of sodium, which is 23, plus 2 times the relative atomic mass of oxygen, which is 16. So it will now be equal to, so it will now be 2 bracket what? 2 times 23 is what? 46, plus 2 times 16 is 32, which will now be equal to 2. So let me use my calculator. So it will now be 46 plus 32, which will now be equal to 78 times 2, which is equal to 156. So it will be equal to 156 gram of what? Sodium peroxide. So that means from the equation, 156 gram of sodium peroxide require what? 2 moles of carbon dioxide gas. 2 moles of carbon dioxide gas will require 2 moles of carbon dioxide, react with 2 moles of carbon dioxide gas, and 1 mole of carbon dioxide gas occupy a volume of what? 24 dn³. So 2 moles of carbon dioxide will occupy a volume of what? 2 times what? 24 dn³, which is equal to what? 48 dn³. 40 dn³. Which will be 48 dn³. That means, which is 48 dn³. That means 156 grams of sodium peroxide react with what? React with 48 dn³ of carbon dioxide. Therefore, 2.4 dn³ of carbon dioxide will require what? What mass of sodium peroxide? So it's as simple as ABC. Will cross multiply. X now will be equal to what? 156 times what? 2.4. So I have to erase so that I have enough space. So I have to erase so that I have enough space. Times 2.4 divided by 48. Let me erase this area. So it will now be 156 times 2.4 divided by 48. So let me use my calculator. 156 times 2.4 will be equal to, divided by 48, which will now be equal to what? 7.8 gram of what? Sodium peroxide. We require 7.8 gram of sodium peroxide. So the answer to this question is what? C. So it's as simple as what? ABC, which is a very straightforward question. I'm Mr. Joseph, your chemistry teacher. Attempt as many questions as possible and reach out to me if you encounter any difficulty. I'm always there for you. I'm Mr. Joe, your chemistry teacher. Feel free to reach out to me. I'll always be there. Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. Still on mass, moles, and volumes. This is a typical examination question. It's an A-level question on mass, moles, and volume. So all you need to do is to read the question and understand the question very, very well before making any attempt. So what is the minimum mass of oxygen required to ensure the complete combustion of 12 dn cube of propane measured under room conditions? Now, the first thing you need to do is you need to understand is that propane is a hydrocarbon, which is a compound of carbon and hydrogen. It's a saturated hydrocarbon with a formula of CN H2N plus 2, where N is equal to the number of carbon atoms. N is equal to 3 for propane. If the hydrocarbon is propane, the number of carbon atoms is equal to what? 3. So the formula for propane will now be C3 H what? H8. So which is propane. So if it undergoes complete combustion, it will produce carbon dioxide and water, which are the product of what? Combustion of hydrocarbons. So the next thing to do is to write the complete balance equation. So this is propane C3H8 undergoes complete combustion with oxygen to produce carbon dioxide plus water, which is H2O. So the next thing to do is to balance the equation. Now make sure that the number of atoms on the reactor is equal to the number of carbon atoms on the product. The number of carbon atoms of the reactor should be equal to the number of carbon atoms on the product. The number of hydrogen atoms on the reactant should be equal to the number of hydrogen atoms on the product. The number of oxygen atoms on the reactant should be equal to the number of oxygen atoms on the product. So on the reactant, carbon is 3, so we'll put 3 here. Carbon is balanced. Hydrogen is 8 on the reactant. Hydrogen is 2 here, so we'll put 4 here. Hydrogen is balanced. So what is left is oxygen. On the reactant, oxygen is 2, while on the product, oxygen is 3 times 2, 6, plus 4 times 1, 4. So 6 plus 4 is 10. So on the product, we have 10 atoms of oxygen, while at the reactant, we have 2 atoms of oxygen. So to balance, we have to add 5 to oxygen. So 5 times 2 is 10. So oxygen is balanced on both sides of what? The reaction, both on the reactant and on the what? Product. Now the next thing we need to do is what? Is to look at, the what is demanded. So we'll have what? Propane and oxygen. What is the minimum mass of oxygen required to ensure the complete combustion of 12 dn cube of propane? So we're dealing with propane and oxygen. So we're going to concentrate on propane and what? And oxygen. And remember, 1 mole of any gas occupies a volume of 24 dn cube. We call it the molar volume of gases. So propane is a gas. So 1 mole of propane will occupy a volume of what? 24 dn cube. So from the equation, 1 mole of propane reacts with what? 5 moles of what? Oxygen. That means 1 mole of propane is equal to what? 24 dm cube. That means 25 dm cube of propane reacts with what? 5 moles of oxygen. So we're going to calculate the mass of 5 moles of oxygen. 5 moles of oxygen. Now the relative atomic mass of oxygen is what? Is 16. So we're going to calculate the mass of 5 moles of oxygen, which will be equal to 5 bracket what? 2 times 16, because we have 2 atoms of oxygen there, which equals to 5 bracket what? 32. So 5 times what? 32. 5 times 32, so it will be 32 times what? 5. 5 times 2, you can write down 0 and carry 1. 5 times 3, 15. 5 times 3, 15 plus 1, 16. So 5 times 32 is equal to what? 160 grams of oxygen. So that means 24 dn cube of propane reacts with what? Reacts with 160 grams of oxygen. So therefore, 12 dn cube of propane will react with what mass of oxygen? So we have to calculate the mass of oxygen, that 12 dn cube of propane. We have to calculate what the minimum mass of oxygen that will be required to combust what? 12 dn cube of propane. So 24 dn cube of propane require what? 160 grams of oxygen. So 12 dn cube will require what? So we have to cross multiply. X now will be equal to what? 12 times 160 divided by what? 24. 12 times 160 divided by 24. So 12 here is 1. 12 here is 2. 2 here is 1. 2 into 160 is what? 80. So the answer is equal to what? 80 grams. So the minimum mass of oxygen required to ensure the complete combustion of 12 dn cube of propane measured under room conditions is equal to what? 80 grams. So the answer to this question is B, which is what? 80 grams. So it's as simple as ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any difficulty. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Feel free to reach out to me. Thank you very much. Hi guys, I'm Mr. Joseph, a chemistry teacher. I'm back with my lectures, still on mass, moles, and volumes. So before us is a typical examination question. It's an A-level question. So you're asked what is the minimum mass of oxygen required to ensure the complete combustion of 12 dn cube of propane measured under room conditions. So the first thing you need to do, you have to read the question very well and understand the question before making any attempt. Now you're asked to calculate the minimum of oxygen required to ensure the complete combustion of 12 dn cube of propane. Now propane is a hydrocarbon, which are compounds of carbon and hydrogen, with a general formula of Cn H2n plus 2, where n is the number of carbon atoms. So for propane, n is equal to 3. So when the hydrocarbon is propane, that means the number of carbon atoms is equal to 3. So the formula for propane to be C3, 2 times 3 is 6 plus 2, H8. So that is propane C3H8. So if it undergoes combustion, it will produce carbon dioxide and water. So the next thing is to do is to write the balance equation so we can calculate the minimum mass of oxygen required to ensure the complete combustion of 12 dn cube of propane. So write the balance equation, which is C3H8 plus what? Oxygen that go combustion to produce carbon dioxide plus what? Water. So the next thing is that you have to ensure that the equation is balanced. So for an equation to be balanced, the number of atoms on the reactant will be equal to the number of atoms on the product. So on the reactant, we have 3 atoms of carbon on the reactant, so we have 1 atom of carbon on the product, so we'll put 3. So carbon is balanced. On the reactant, we have 8 atoms of hydrogen. On the product, we have 2 atoms of hydrogen, so we'll have to put 4 here. So 4 times 2 is equal to 8. So hydrogen is balanced on both the reactant and the product. Then what is left is oxygen. On the product, we have 3 times 2, 6 plus 4 times 1, which is 4. So that means 6 plus 4 is 10. We have 10 atoms of oxygen on the product and 2 atoms of oxygen on the reactant. So you put 5 here to balance the equation, to make sure that the equation is what? Balanced. So on the reactant, we have 10 atoms of oxygen, while on the product, we have 10 atoms of what? Oxygen. So the equation is what? Balanced. So the next thing to do is what? Is to calculate the minimum mass of oxygen required to ensure the complete combustion of 12 dn cube of propane. Now you have to know that 1 mole of any gas occupies a volume of what? 24 dn cube, which is known as what? The molar volume of gas. So 1 mole of propane gas will occupy a volume of what? 24 dn cube. So we should calculate the mass of oxygen required to ensure the complete combustion of what? 12 dn cube of what? Propane. So from the equation, 1 mole of propane reacts with 5 moles of oxygen, while 1 mole of propane is equal to 24 dn cube. That means 24 dn cube of propane reacts with what? 5 moles of what? Oxygen. 5 moles of what? Oxygen. Therefore, 12 dn cube of propane reacts with what moles of oxygen? So we have to calculate the number of moles of oxygen that 12 dn cube of propane will react with. So you cross multiply. So x now will be equal to what? 12 times 5 divided by what? 24. So it will now be equal to 12 here 1, 12 here 2. So what will be left is what? 5 over what? 2. Then if I'm to use my calculator to put it in decimal, so it will now be what? 5 divided by 2, which will now be equal to 2.5 moles of what? Oxygen. That means 12 dn cube of oxygen, 12 dn cube of propane will react with what? 2.5 moles of oxygen. So, but we have to calculate what? The mass of oxygen. So since we've gotten the number of mole of oxygen, we'll now use our formula. Number of mole is equal to what? Mass over what? The molar mass. So the mass of we have to, so we'll use the formula N is equal to mass over molar mass, which is number of mole is equal to mass over molar mass. So the mass now will be equal to what? The number of mole multiplied by what? By the molar mass. So the mass now will be equal to what? 2.5. I think I have to erase this so I'll have enough space. So I have to erase this. So mass now will be equal to what? Number of moles times molar mass. The number of moles is what? 2.5 times the molar mass of oxygen. Molar mass of oxygen is equal to what? 32, which is what? 2 bracket was 16. 2 times 16 is equal to what? 32. So the mass now will be equal to what? 2.5 times 32. So I have to use my calculator times 32, which is equal to what? 80 grams. So the mass of oxygen required to ensure the complete combustion of 12 dn cube of propane measured under room conditions is equal to what? 80 grams. So the answer is what? B. So it's as simple as what? ABC. All you need to do is just to read the question very, very well, attempt as many questions as possible, and feel free to reach out to me if you encounter any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you. Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. Today we're looking at a typical examination question, A-level Cambridge International Exam, A-level question on mass, moles, and volumes. It's as simple as ABC. All you need to do is to look at the question critically, read the questions very, very well, and understand every step or every statement that is written. And I believe you should be able to do justice. Now, the question before us is a sample of propane, C3H8, with a mass of 9.61 grams is completely combusted in an excess of oxygen under room conditions. You are now asked which volume of carbon dioxide gas is produced. So the first thing you need to do is to write down the balance equation. Propane undergo combustion reaction. Propane is a hydrocarbon. And what are hydrocarbons? Hydrocarbons are compounds of carbon and hydrogen. So propane. So the first thing we write the balance equation, which is C3H8, which is propane. C3H8, which is a hydrocarbon, react with oxygen to produce what? Carbon dioxide plus water, which are products of combustion of hydrocarbons. So the next thing to do is to balance the equation. It's as simple as ABC. Make sure that each atom on the reactant and the atom on the product are the same, just to balance the equation. The number of atoms of carbon on the reactant must be equal to the number of carbon atoms on the product. The number of hydrogen atoms on the reactant must be equal to the number of hydrogen atoms on the product. The same thing with what? Oxygen. So carbon is 3 here, so we'll put 3 here. Carbon is balanced. Carbon is 3 on both on the reactant and on the product. Hydrogen is 8 here, but hydrogen does 2 here, so we'll put 4 here. So hydrogen is balanced on the reactant and hydrogen is balanced on the product. What is left is oxygen. So on the product, we have 3 times 2, which is 6, plus 4. Oxygen here is 4, so 6 plus 4 is 10. So on the product, oxygen is 10. 3 times 2, which is 6 atoms of oxygen, plus 4 atoms of oxygen from the water molecule. So 6 plus 4 is 10. So on the product, oxygen is 10. On the reactant, oxygen is 2. So we'll have to put 5 here. So the equation is balanced. Now the next thing to do is to focus on the reactant or the product that is needed. Now from the equation, a sample of propane with a mass of 9.61 grams is completely combusted in an excess of oxygen under room conditions. So oxygen is in excess. So which volume of carbon dioxide gas is produced? So we are dealing with propane and carbon dioxide gas. We're dealing with propane and what? Carbon dioxide gas. Now, under room conditions at ROTP, 1 mole of any gas, 1 mole of any gas, 1 mole of a gas occupy a volume of 24 dm cube. Occupy a volume of 24 dm cube. And we'll have 3 moles of carbon dioxide gas, which is a gas. That means 3 moles of carbon dioxide gas occupy a volume of what? 3 times 24. 3 times 24. 3 times 24. I'm to use my calculator. 3 times 24, which is equal to what? 72 dm cube. That means 3 moles of carbon dioxide gas that is produced occupy a volume of what? 72 dm cube. So from this, when 1 mole of propane, so we're going to calculate the mass of 1 mole of propane. So it's as simple as ABC, which is the molar mass. Carbon is 12, so it is 3 bracket 12, plus hydrogen is 8, 8 bracket 1, So it will now be equal to 3 times 12 is what? 36. 36 plus 8, which will be equal to what? 36 plus 8 is 44. 44 gram. That means 44 gram of propane, which is C3. Let me use the formula C3H8, occupy a volume of what? 72 dm cube, which is 3 moles of carbon dioxide gas. 72 dm cube of what? Carbon dioxide gas. You are now asked which volume of carbon dioxide gas is produced when a mass of 9.61 gram is completely combusted. So when we combusted 44 gram of propane C3H8, 72 dm cube of carbon dioxide was produced. So for 9.61 gram of what? Propane. So I want to calculate the volume of carbon dioxide gas produced. So I have to erase this so that I will have enough space. So it's as simple as ABC. So I need to erase this so I'll have more space. So what to do is we'll cross multiply X now, which is the volume of carbon dioxide gas produced, will now be equal to what? 9.61 multiplied by 72 divided by what? 44. So I'm to use my calculator now. I'll now have 9.61 gram times 72 dm cube is equal to divided by 44, which will now be equal to what? 15.72 dm cube, which is approximately 15.7. So the correct answer to this question is D. So it's as simple as what? ABC. So just attempt as many questions as possible and reach out to me if you encounter any difficulty, any challenge. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Reach out to me if you encounter any difficulty. It's as simple as ABC, just the way you eat jollof rice and chicken. So it's very, very simple. Thank you very much. Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. Before us is a typical examination question. It's an A-level question, Cambridge International Examination. It's an exam style question, so it's as simple as ABC. All you need to do is to read the question very, very well and understand each step that is, stated. Then you can easily solve the question. Now, a sample of propane, which is C3H8, with a mass of 9.61 gram is completely combusted in an excess of oxygen under room conditions. So please, I want you to take note of that. Which volume of carbon dioxide gas is produced? So the first thing you need to do is you need to take note of the fact that propane is what? It's a hydrocarbon, which is the compound of carbon and what? Hydrogen. So undergo combustion. Whenever hydrocarbons undergo combustion, they produce what? Carbon dioxide and water. So we're going to write the balance equation for the reaction, which is C3H8 plus what? Oxygen. So it will produce carbon dioxide plus water. The next thing you need to do is to look at the equation and ensure that the equation is balanced. For the equation to be balanced, that means the number of carbon atoms on the reactant must be equal to the number of carbon atoms on the product. The number of hydrogen atoms on the reactant must be equal to the number of hydrogen atoms on the product. The number of oxygen atoms on the reactant must be equal to the number of hydrogen atoms on the product. We say the equation is balanced. So let's balance the equation. On the reactant, carbon is 3, so carbon will be 3 here. We'll put 3 here, so carbon is balanced. Hydrogen is 8 on the reactant. Hydrogen is just 2 here on the product. So we'll have to add 4 here. 4 times 2 is 8. So hydrogen is balanced. Then on the product, oxygen is 10. 3 times 2 is 6 plus 4, which is 10. So oxygen is 10 on the product, but on the reactant, oxygen is just 2. So add 5 here to make sure that the equation is what? Balanced. Now from the question, they say a sample of propane has a mass of 9.618 gram, which is combusted. So we're going to calculate the number of moles of what? 9.61 gram of propane. Now number of moles is equal to what? Mass divided by the molar mass. So what is the mass of propane? 9.61 gram. Then the molar mass of propane, molar mass, carbon is 12, so 3 bracket 12 plus hydrogen is 8, 8 bracket 1, that's the relative atomic mass of hydrogen. So 3 times 12 is 36. 36 plus 8 is equal to what? 44. So the molar mass of propane, which is the mass of 1 mole of propane, is equal to what? 44. So I'm to use my calculator, which will now be equal to what? 9.61 divided by what? 44. So you have what? It will now be equal to what? 0.2184 what? 84 moles of what? Moles of propane is combusted. Now let's go to the equation. Now we're going to concentrate on what is needed. So propane. So we need what? Propane and what? Carbon dioxide gas. So from the equation, 1 mole of propane undergoes combustion to give you 3 moles of carbon dioxide gas. And I want you to know that 1 mole of any gas is under room conditions. 1 mole of any gas occupies a volume of 24 dm cube. 1 mole of any gas occupies a volume of 24 dm cube, which is known as what? Molar volume of gas. So from the equation, 1 mole of propane, C3H8, produces what? 3 moles of carbon dioxide gas. And 1 mole of carbon dioxide gas is equal to 24 dm cube. Therefore, 3 moles of carbon dioxide gas will be equal to what? 3 times what? 24 dm cube, which will now be equal to what? 72 dm cube. That means 1 mole of carbon dioxide gas produces what? 72 dm cube of what? 1 mole of propane produces 72 dm cube of what? Carbon dioxide gas. So 1 mole of propane produces 72 dm cube of carbon dioxide gas. Therefore, 0.2184 moles of propane will produce what volume of carbon dioxide gas? So it's as simple as ABC. All we need to do is just cross multiply. So it will now be 0.2184 times 72 divided by what? 1, which will now be equal to, so I have to use my calculator, times 0.2184 times 72, which will now be equal to what? 15.72 dm cube, which is approximately what? 1 decimal place 15.7. So the answer is what? D. So it's as simple as what? A, B, C. So 0.2184 moles of carbon dioxide gas is going to produce what? 15.72 dm cube. That is the volume of carbon dioxide gas that is produced when 9.61 gram of what? Propane is completely what? Combusted. So it's as simple as what? A, B, C. Attempt as many questions as possible and reach out to me if you encounter any difficulty. It's as simple as A, B, C. The answer is D, which is 15.7 dm cube. Mr. Joe, your chemistry teacher. Thank you very much. Subscribe to my YouTube channel, Joe Mystery. Like, share, comment, and reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Please don't forget to subscribe to my YouTube channel. Thank you very much.